some basic questions about intermolecular forces. And I'd like to answer this last question first. What's the evidence that all neutral atoms and molecules exert attractive forces on each other? We're looking for evidence that everything sticks to everything, and it's that any element or compound is going to condense into the liquid or solid phase if it gets cold enough. In other words, it's all relative. We are going to consider the kinetic energy of the particles versus the force that is holding them close to each other, the stickiness between particles. We know when we discussed the kinetic molecular theory that the average kinetic energy of particles increases with temperature. If we start with a gas, the average kinetic energy of particles is higher than the force that's going to hold them closer to each other. Gases, high temperature, they have a high average kinetic energy, and in fact that kinetic energy is much stronger than that needed to overcome the stickiness to IMFs. So these particles are not stuck to each other, but rather are free to move wherever they would like. If we lower the temperature, i.e. lower the average kinetic energy, these particles eventually become stuck to each other, where their stickiness is forcing them to remain close to each other, but they still have enough kinetic energy that they can slide past each other. They're not stuck in place. Finally, we have the situation of the solids. The lowest temperature, lowest kinetic energy, particles are stuck in place. They no longer have enough kinetic energy to slide over top of each other. However, they still vibrate back and forth. Everything sticks to everything. We just want to consider the extent of intermolecular forces versus the kinetic energy of these particles. If there's a lot of kinetic energy of the particles, they're free to move about the entire container. They expand to fill all available spaces. If we lower the kinetic energy, lower the temperature, eventually the particles are going to be stuck next to each other, but in a liquid, they can slide over top of each other. That's how they can assume the shape of the bottom of a container. Solids are achieved when we lower the kinetic energy further, lower the temperature further, and the particles are actually stuck in place because they no longer have enough kinetic energy to slide over top of each other. All right, now let's look at the rest of these questions. All right, let's look at liquids versus solids. How are they different and how are they similar? They're both composed of particles, atoms, ions, or molecules. Both liquids and solids are incompressible. And this is because there's very little space, if any, between the particles. Because there's very little space between the particles, liquids and solids tend to have very similar densities. And in fact, their densities tend to be measured in grams per milliliter. This contrasts to gases, which have a much, much lower density and in fact are typically measured in grams per liter. So how are these different? Okay, solids have a very rigid structure. Okay, they pretty much hold their shape. Because the particles are locked in position into some form of a lattice structure, they hold their shape. Okay, whereas liquids can flow over each other to fill the bottom of a container.